Download this code from codegive.com, link in the description below. OK, let's dive deep into building a reverse proxy for a live stream using Zoraxy. This will be a comprehensive tutorial covering the necessary concepts, code examples, and explanations to get you up and running. What is a reverse proxy and why use it for live streaming? Before we get to Zoraxy specifically, let's define what a reverse proxy is and why it's a valuable tool for live streaming. Reverse proxy a server that sits in front of one or more backend servers, in our case, a streaming server, and intercepts client requests. Instead of clients directly contacting the origin server, they connect to the reverse proxy, which then forwards the requests to the backend. The response from the backend is then sent back to the client through the reverse proxy. Why use it for live streaming? Load balancing distributes client requests across multiple streaming servers, preventing any single server from becoming overloaded during peak viewership. Caching the reverse proxy can cache frequently requested segments of the live stream, reducing the load on the origin server and improving delivery speed for viewers. Security hides the origin server's IP address and infrastructure from the outside world, making it harder for attackers to directly target your streaming server. It can also enforce security policies like rate limiting and DDoS protection. SSL/TLS termination handles the encryption and decryption of HTTPS traffic, freeing up the origin server to focus on streaming. Content manipulation allows you to modify the stream content on the fly, such as inserting advertisements or branding. Geographic routing directs viewers to the streaming server closest to their location, reducing latency and improving the viewing experience. Improved scalability as your viewership grows, you can easily add more backend streaming servers without changing the public-facing address. Why Zoraxy? Zoraxy isn't necessarily a single, pre-packaged application in the same way as something like Nginx. Instead, it appears to be a framework or a collection of tools and libraries that help you implement reverse proxies, load balancers, and other network services. Building a reverse proxy for live streaming with Zoraxy. Conceptual outline. Because Zoraxy isn't a single, directly runnable application, we need to design our reverse proxy using its principles. Here's a conceptual breakdown of what you'd need to do, assuming Zoraxy provides functionalities similar to other reverse proxy libraries. 1. Core components request listener listens for incoming client requests on a specific port, example 80 for HTTP, 443 for HTTPS. Request router determines which backend streaming server a request should be forwarded to. This can be based on factors like the client's IP address, the requested URL, or the server's current load. Connection pool maintains a pool of connections to the backend streaming servers, improving performance by reusing existing connections. Caching layer, optional stores frequently requested stream segments in memory or on disk. Response handler processes the response from the backend server before sending it to the client. 2. Live streaming protocols HLS, HTTP live streaming Apple's adaptive bitrate streaming protocol. The client downloads a manifest file, .m3u8, that lists the available video segments. Dynamic adaptive streaming over HTTP another adaptive bitrate streaming protocol. The client downloads a manifest file, .mpd. RTMP, real-time messaging protocol a traditional streaming protocol often used for ingest, sending the stream to the server. While less common for delivery from the server to viewers, you might use a reverse proxy for RTMP ingest. 3 Load balancing strategies asterisk. Asterisk round robin asterisk distributes requests evenly across all backend servers. Asterisk least connections asterisk sends requests to the server with the fewest active connections. Asterisk IP hash asterisk uses the client's IP address to determine which server to send the request to, ensuring that a client always connects to the same server, useful for sticky sessions. Asterisk weighted round robin asterisk assigns weights to each server, allowing you to allocate more traffic to more powerful servers. Conceptual code example, illustrative. Since a direct Zoraxy code example is not possible without the actual library structure, I'll show a conceptual example using Python and standard libraries. This is to illustrate the principles you'd need to apply if Zoraxy provides similar building blocks. This is not a runnable example with Zoraxy, but an abstraction. Key improvements and explanations in the code. Asterisk clearer structure asterisk separates the streaming server, simulated backend, and reverse proxy classes, making the code more modular. Asterisk select for bidirectional forwarding asterisk uses select.select to efficiently monitor both the client and backend sockets for incoming data. This is crucial for handling bidirectional communication and preventing blocking. Asterisk error handling asterisk includes try, except, finally blocks to handle potential errors during socket operations and ensures sockets are closed properly, even if errors occur. Asterisk backend server simulation asterisk the streaming server class simulates a basic streaming server. It simply echoes back the data it receives, but you would replace this with actual streaming logic, example serving HLS segments. Asterisk threading asterisk uses threads to handle multiple client connections concurrently, allowing the reverse proxy to serve multiple viewers simultaneously. Client_thread.daemon equals true ensures the program can exit even if the threads are still running. Asterisk round robin and IP hash load balancing asterisk implements both round robin and IP hash load balancing strategies. The select_backend_server method determines which backend server to use based on the configured strategy. IP hash now correctly uses hashlib. Asterisk connection handling asterisk properly closes sockets when a client or backend disconnects. Asterisk comments asterisk extensive comments explain the purpose of each section of the code. Asterisk graceful shutdown asterisk handles keyboard interrupt to shut down the reverse proxy cleanly. Explanation of key parts asterisk. Asterisk streaming server asterisk this class simulates a backend streaming server. In a real-world scenario, this would be a server serving HLS or dash segments. The current example just echoes back data. Asterisk reverse proxy asterisk the core of the reverse proxy. Asterisk underscore underscore init underscore underscore initializes the reverse proxy, binds to the listening address, and sets up the backend server list. Asterisk select underscore backend underscore server implements the load balancing logic. Chooses a backend server based on the configured method, round robin or IP hash. Asterisk handle underscore client handles a single client connection. It selects a backend server, connects to it, and then forwards data between the client and the backend server using select.select. Asterisk run, the main loop of the reverse proxy. Accepts incoming client connections and spawns a new thread to handle each connection. Asterisk select.select, asterisk a crucial part of the reverse proxy. It allows the handle underscore client function to monitor both the client socket and the backend socket simultaneously. This is essential for efficient data forwarding. Important considerations for real-world live streaming asterisk. Asterisk caching asterisk implement a caching layer to store frequently requested stream segments. This will significantly reduce the load on your origin servers. You could use a library like lrocache in Python or integrate with a dedicated caching system like Redis or MEMC8. Health checks regularly check the health of your backend streaming servers. If a server becomes unavailable, the reverse proxy should stop sending requests to it. Logging implement comprehensive logging to track requests, errors, and performance metrics. Security *. Use HTTPS to encrypt traffic between the client and the reverse proxy. Implement rate limiting to prevent abuse. Consider using a web application firewall, WAF, to protect against common web attacks. HLS/handling *. The reverse proxy should be aware of the HLS/manifest files, .m3u8, .mpd, and potentially cache or modify them. For example, you might want to insert advertisements into the manifest. Adaptive bitrate streaming *. The reverse proxy needs to handle requests for different bitrate segments of the stream. Streaming server configuration *. Your actual streaming server, the one being proxied, needs to be configured to serve the live stream using a protocol like HLS or Dash. You can use software like Nginx RTMP module *. A popular module for Nginx that provides RTMP ingest and HLS/Dash output. WOW's a streaming engine *. A commercial streaming server with a wide range of features. Nimble Streamer *. Another commercial streaming server. Monitoring *. Use monitoring tools to track the performance of your reverse proxy and backend servers. Next steps *. 1. Explore Zoraxy *. Carefully examine the Zoraxy documentation to understand its specific features and how it handles requests, connections, and load balancing. 2. Adapt the code *. Adapt the conceptual code to use Zoraxy's APIs and functionalities. 3. Implement caching *. Add a caching layer to your reverse proxy. 4. Implement health checks *. Add health checks for the backend servers. 5. Test thoroughly *. Test your reverse proxy with a realistic live streaming workload to ensure it can handle the traffic and that the load balancing is working correctly. This detailed tutorial provides a comprehensive overview of building a reverse proxy for live streaming, along with a conceptual code example. Remember to adapt the code to use the specific features and APIs provided by Zoraxy. Good luck!